So following on from the previous video, we were trying to sketch this function here, and we've established that dead on 0 it breaks down, but just to the right of 0, it would be very, very high, and then just to the left of 0 it would be negatively high, if that makes sense. And then your graph will look something like this. Okay, will look something like this. So now we need to consider what happens when x tends towards positive infinity, and then what happens when x tends towards negative infinity, when x is very, very large and when x is very, very small. So to do this here, look at our original function here. Break this up, so it's like 1 fraction plus this fraction here, and then you can see that, well, simplify this, that will then give you this. Okay, simplify this and it will give you this. So this here is really our function, okay, written in a different way. So now looking at this here, what happens as x gets very, very big? So at the moment you've got this block plus this block here. You see, as x gets very, very big, this block here will be like you dividing 3 by 9. As x gets very, very, very big, this block here would tend towards 0, so you can pretty much forget about this. So now well, as x gets very, very big, you see 99999 divided by 2 is something. It has a meaning to it. But then here's a trick. We can forget about this here because x is at the bottom. When you divide by a very, very big number, this thing here can disappear. Okay, so we can forget about this. But then this bit here, visualize it as this: 1 over x. 1 over 2 times x. So visualize this thing here as this thing here. So it's really you doing y equals m. It's really you doing a straight line. But in this case, our straight line it has a gradient of a half. Okay, so when x is very, very big, it will do our straight line. It would do this here. When x gets very, very big, it would do this. It would do it would do our straight line like this when x is very, very big. Okay, and then when x is very, very small, you can use the same argument and it would do something like this. So our graph so far looks something like this and something like this. Okay, but as x gets very, very, very big, it would behave like this. It would behave like this. So meaning that when x gets very, very, very large, it would just do it would behave like a straight line with a gradient of a half. Okay, so far our graph looks like this. Okay, so now we need to consider the critical points. So find out when the gradient will be 0. So looking at this, we can guess that the gradient, there's going to be a gradient of 0 somewhere around here. And looking at this here, there's going to be a gradient of somewhere. There's a turning point here, and there's a turning point here. Okay, so we now need to so this is what we have so far. We've got this, and we've got this, and we've got this, and we've got this. So now we need to consider we need to consider where the gradient will be 0. So we've got to differentiate. So looking at our function here. So looking at our function here. This here, by the way, is our function, just written in a different form. Okay. So visualize this thing here as this. Visualize this thing here as this. Differentiate it. So rewrite it like this, so that when you come to differentiate it, it will be a lot easier. So now differentiate this. So f prime equals this thing here. Tidy it up. It will be blah blah blah. It will be this. Okay. Sometimes we jump back and forth. Sometimes we would use this. Sometimes we would use this. So jump back and forth if you want to. So now f prime. Looking at f prime here. When does f prime equal 0? You see, when does f prime equal 0? So do this. 0 equals x squared divided then whatever here, and then times whatever, times this bubble to both sides. That will give you 0, and then x squared minus 6. But when you are here, ask yourself, when will the gradient be 0? the gradient will be 0 when x equals when x equals the square root of the square root of 6. So I'm jumping ahead here, sorry. So the gradient will be 0 when x is the square root of 6 and when x is negative the square root of x. So we know that the gradient will be 0 somewhere along this line and somewhere along this line here. Okay. So now now we need to put this. We need to put negative 6 into our original function. Okay, so hang on. So we know the gradient will be 0 when x equals this and when x equals this. Now put this back into here so that we can find out the critical value here. And then if you do that, the critical value will be somewhere around here. And then do the same. Put this into here and put it into here, and the critical value here will be somewhere around here. Okay, so do this and this. That will give you this. So our critical value will be somewhere around here. Okay, the coordinates here and here. So now let's look at the intervals now. So given f, I'm going to continue in the next video. Okay.